Hey there, everybody, and thanks for tuning in to the Daily Space Weather. Talk about accurate forecasting. It's all about understanding the physics and the correlation between the sets of data. Another fascinating space weather video coming at you today from the Smash News Network, least busted name in news. As spring comes to a close, spring is almost over, folks. Summer is almost here, or if you're in the southern hemisphere, winter. And accurate forecasts are what's up with the channel. We'll talk about it. And plenty more. These images are from SDO, the Solar Dynamics Observatory. You're looking at ionized helium in 304 angstroms. And these are indeed the most active portions of the closest star at the moment. These sunspot groups up in the northeastern limb have been the culprits for most of the solar activity in the past 24, but don't worry. We're not going to forget to show you a holistic view of the closest star. Because when it comes down to stargazing, that's the most interesting one to look at. We've got, shall we say, a lot of detail. And look at the size of this filament. This filament right here is pretty berserk. Check it out. It is, 200 Earth diameters in length. It's kind of big, and it's starting to look kind of unstable. And there's a CME happening as we produce this video. So, the sun doesn't really take days off, and neither does our channel. We put out videos with this level of detail every day for pushing 6 years. So there's a close-up of that gigantic filament there, and you can see great depth to it also, as it is thousands of kilometers above the solar surface. Southern hemisphere features a massive filament as well. This one down here has been named. We've been naming filaments after living people. That one's known as the Cornell West. Yeah, the Cornell West filament. Shout out to my comrade and brother, Cornell West. Again, we forecasted a sunspot rising in the southeast yesterday. It's all about understanding the physics and the correlation of the data. Indeed, there is a new large sunspot that just rose in the southeast as forecast. There is the full eastern limb, and it is where you can expect to continue to see the most activity here when it comes to space weather. And when it comes to space weather, nobody does it like the Smash News Network, least busted name in news. I'm pretty convinced that nobody can. Certainly nobody does. So here is yesterday plus today in the SDO HMI instrument. And you can see most of the activity here in the southern hemisphere. And these groups that should have gotten names yesterday have evaporated since then. So we've got another situation here with sunspot groups that ought to have been named, but haven't been. Why? Reasons. Because reasons, folks. Anyway, here's the colorized magnetogram. And this sunspot that rose down here in the southeast, that'll certainly get a name. It is way too big to not get a name. And let's take a look at some additional stats here. What's going on Crescent Earth. So it looks like volcanic activity has dipped since yesterday. Also, the solar wind has gotten very diffuse. We'll get to it. As far as volcanoes go, Sakurajima is erupting and producing a 6,000-foot plume of volcanic ash. It's a flight level 060. Similar size ash plume from Subanose-jima. Mount Mayon, 9,000-foot ash plume there as Mayon continues to erupt. Popocatépetl exploding in central Mexico, flight level 210. It's a 21,000-foot ash plume and 25,000-foot ash plume over Sabancaya in Peru. It's a flight level 250. And moving on to seismic activity, the largest quake of the past 24 hours was a 6.2. That is a 90-day bar graph from volcanodiscovery.com. There's the largest quake over the past 24 in between Tonga and New Zealand, the most seismically active portion of the planet. Over the past couple of days, that 6.2 came in at 1910 Universal Time, and we actually sent out an email alert to the Smash team about that at smashomash.com/SmashTeam. So if you're signed up for email alerts, you may have seen an email alert about that. That email alert came out before any USGS alerts. So if you are signed up for email alerts, you should have received that quite promptly indeed. By the way, that quake did not generate a tsunami, apparently. There was no tsunami warning, advisory, watch, or threat issued. We looked at the individual lists there. No tsunamis reported. Anyway, we'll report quakes over a 5 magnitude or higher. And of course, this one made the rounds, a 4.8 in France. Not very common. Not very common for us to cite any quakes in Western Europe. So preceding that 6.2, there was also a 5.0 in that same region there, southwest of Tonga. There's that 6.2. Again, that was at 1910 Universal Time. There was also a 5.5 as aftershocks continue following some 7 magnitude activity in that area a couple of days ago. There was also a 5.6 near Japan. That was at 0:26 this morning on June 17th. Southern Panama also had a 5.3. That was at 4:58 this morning on the 17th. And last but not least, the Philippines had a 5.5. That was at 10:15 Universal Time while we were doing show prep. And getting back to space is my priority. Here's the past 24 hours. From SDO in 171 angstroms. By the way, if you hadn't seen yesterday's shorts on the channel, you can share those with your favorite low attention span social media users. Let's get to some more space weather stats. The 10.7 centimeter radio flux, now at 157 solar flux units. I'm expecting this to continue to rise. We've got a number of significant sunspot groups rotating into the Earth strike zone. There is the 1-year graph of the 10.7 centimeter radio flux depicted by this black line. The sun having just broken out of the 155 solar flux units range. As you can see, that has been a support level for the past year. And we may be seeing a big breakout happening. Let us know in the comments what you think. Do you think we're going to get back over 234, the previous peak during this cycle of the 10.7 centimeter radio flux? The red line below it there is a sunspot number. The blue line is the Potsdam AP, which is just an average of the KP index, earthly geomagnetism. You can see we had quite a big uptick here in the past couple of days from a coronal hole high-speed stream. The Space Weather Enthusiast dashboard here, let's see, not forecasting any geomagnetic unrest until the 19th. So that sounds like an agreement with our CME impact forecast. And let's see what they have to say about that. This is the NOAA forecast, the NOAA Enlil spiral. And they're forecasting a little uptick there. It looks like a coronal hole high-speed stream, not a coronal mass ejection impact. So if you didn't see our video yesterday, we did forecast a minor glancing blow type coronal mass ejection impact. I won't cover it again today because we covered it yesterday. So let's also check and see what's going on here for NASA's forecast, because NASA's got a little bit more skin in the game than NOAA does, because of course astronauts' lives depend on accurate forecasting. So let's see what we have here. We're going to show the inner planets view and plasma density. And it looks like NASA believes those CMEs to be not earthly directed, so we'll just have to see what happens here. We are expecting some CME impacts. Again, watch yesterday's video if you're not familiar with when we forecasted them. Here's the past 4 hours of Earth's magnetic moment from the ground, and we're seeing a subsiding of the coronal hole high-speed stream. You'll see the plasma here trying to reach static equilibrium. That's what you see happening there on the right when you see the magnetotail with higher plasma density than the bow shock side, which would be on the left, the side that faces the sun. That's the past 4 hours of Earth's magnetic moment from space. We've got a very diffuse but considerably high-speed solar wind. Here's Earth's magnetic moment from the ground for the past 4 hours. This is shown daily on the channel as well. And these are the most likely places to see telluric currents, the aurora, pipeline, railway, and power grid induction. And it's a great place to tell people that, yeah, Earth's poles aren't flipping. Do you see quadrupoles? I certainly don't. That's the past 4 hours of Earth's magnetic moment from the ground. Here's an average of Earth's geomagnetism, the planetary K index, currently at 2. KP2 is the current situation. It's geomagnetically calm conditions because of a high-speed but very diffuse solar wind. So there's the last day in terms of solar wind. And, yeah, very high-speed solar wind, but very low density indeed. So the current condition is only 0.7 protons per cubic centimeter. Solar wind speed here still elevated at 570 kilometers per second. The rest of that is unremarkable, as we're watching a coronal hole high-speed stream subside. GOES magnetometers here showing very much lower highs and lower lows here than the past couple of days. We had one very high reading here. We got all the way up to 185 nanotesla as measured by the GOES 16. That was the initial impact of the coronal hole high-speed stream. So that was interesting. Since then, again, it has subsided, and we're seeing a big increase likely coming in the electron flux. We already see an increase in the electron flux. We'll get to it in our bonus features segment. Now, let's talk about the Gong 2 data. Now, yesterday, we talked about how we're expecting to see a sunspot rise in the southeast based on this data right here, this potential field surface source data. So that is depicting the magnetic polarity of the heliospheric current sheet, and it gives us insight into what's happening in terms of solar activity. So let me just put on the headset here for a quick moment while I play a clip from yesterday's video, as we put lots of clips in our shorts so the people with short attention spans again can see the content. So check it out. May see a southern sunspot here about to rise or form in the southeast. Yeah, the southeast. So keep an eye on that. That's a forecast based on the top view ecliptic plane field plot. We may see a southern sunspot here about to rise or form in the southeast. Sounds like a forecast to me, and it was based on this. It's not because I looked at the data from stereo A and saw a sunspot rising. Nope, it was only based on this data because of an understanding of the correlation between the magnetic data and solar actual activity. Anyway, here's our line of sight field plot. Nothing too exciting happening there. And by the way, Earth is remaining in a South Pole current sheet here for the time being. Although one important thing to note is that this strong magnetic field at the North Heliographic Pole remains in place. So until that leaves, I will not be declaring solar maximum. We just aren't there yet based on all of these data sets. So let's move to coronal holes next. They are super important as they depict the solar polar field reversal process, which occurs throughout each solar cycle, completing its process in 2 solar cycles, a period of about 22 years. So there you can see a lot of South Pole magnetism popping up, a bunch of coronal holes looking like they're opening up there around the North Polar region. That is super interesting indeed. Check it out. I don't think we've ever covered that on the channel before. Let's see if it shows up in the 211 angstroms wavelength here from SDO. So this is the past 24 hours. And looking for coronal holes opening up there, so it's not super obvious in this wavelength, but it does show up in the magnetic data. So right there in the past 2 days, a whole bunch of very far north, south pole oriented coronal holes showing up there just south of the north heliographic pole. Again, there it is in 211 angstroms from SDO, the Solar Dynamics Observatory. So right up here, a series of new coronal holes have just recently formed. Anyway, it's about time to move to sunspots. Since those are important features just like coronal holes, I don't really view either of them as more important or less important. So let's go to sunspots, which occur all the way down in the photosphere layer. So, the main difference between sunspots and coronal holes, folks, is that they are a completely different layer of the sun. Coronal holes occur in the sun's atmosphere, and sunspots occur in the photosphere, 2 layers lower. So you've got the chromosphere in between the photosphere where sunspots occur and the corona where coronal holes happen. Here's what's going on in the photosphere. So we do have one new group that will get named. You can see it here popping up over the limb. It's quite a large sunspot. At the moment, I only see one umbral polarity, so it is alpha class at the moment. That'll be sunspot number 3339. Since these two up here never got names and have since evaporated, that'll be sunspot 3339. And I have a stinking sensation, not to be confused with a sinking sensation, that somebody is failing to count sunspots on purpose. Maybe because they've badly forecasted solar cycle 25. Just saying, because there is a lot of argument about what is going on with solar sunspot cycles. Not sure about that, but that's the current situation. Likelihood of large flares remains kind of high here. We've got multiple large sunspot groups that are magnetically complex. Beta-class sunspot groups, the kind most likely to produce large flares. Anyway, here is a close-up of the equatorial region featuring 171 angstroms plus the SDO HMI continuum. And let's drop the 171 angstroms. I mean, really, there were 3 sunspot groups up here in the northwest. I'm not sure if they failed to name 2 or failed to name all 3. I think they failed to name all 3 of those. So not sure what's up with that. Not pleased about it. We've seen this happen several times in the past couple of weeks. Sunspots that have been there for days and just never got names, or it took 3 days to name a sunspot that had been there the whole time. So not sure exactly what's going on with that. And we don't follow all the different sources that name sunspots. There are different groups that name sunspots, and I won't get into the minutia of that. But like we forecasted yesterday, a new sunspot did indeed rise in the southeast. Again, that's called understanding how the data correlates. And let's move on to energetic particles and solar flares. So the proton flux here, no spikes, no solar energetic particle events going on recently here. We did see some M-class flares, 3 of them yesterday. And once again, a little flare happening here as we produce the video. Looks like a C3 class flare. Has it already leveled off? Maybe. Or maybe it's a predecessor to a larger flare. Who knows? But we usually show the 3-day chart, so there is the 3-day chart from the GOES 16 and GOES 18 X-ray measurements. And let's take a look at solar. Let's take a look at some more imagery here. That's 94 plus 131 angstroms. Oh, we did have a flare from down here also. So a flare down here in the southwestern limb. But the most activity here is still in the east. So that remains the most likely place to see large flares. Let's take a little trip around the horn here in these wavelengths, as they are a higher temporal resolution. They take more images per minute. That is 94 and 131 angstroms. They take 10 images per minute instead of only 2 images per minute. Like the other wavelengths, they are specifically formulated to view solar flares. Here's an inset of the western limb, complete with one significant flare down there in the southwest. And here is the eastern limb. Again, that is where the most sunspots are located. They're large, they're magnetically complex, and they are certainly capable of producing significant flares. Next, we're going to show you a star chart because it's important to some people what's going on overhead and so forth. Of course, we've got, let's see, are we at new moon? We're very close to new moon here. And at the moment, no moon. Oh, the moon's there. So we must have new moon. I don't see any kind of phasing. So happy new moon to all my reverse werewolves out there. And yeah, it's a great time to view the evening sky here, especially, I would say, especially after dusk. In that if you're viewing after dusk, you'll see Mars and Venus very close together there, just to the north of the ecliptic, the path the sun takes across the sky. And before we move on here, take a moment to support the channel via our paid affiliate/sponsor links. One of those is Hemp Lucid. So if you are doing shopping at Hemp Lucid, don't forget to enter the promo code SMASHOMASH. Yeah. Enter the promo code SMASHOMASH during checkout for your hemplucid.com orders and save 10%. You can also shop via our links. That also gives us credit. So perhaps try some of these things out if you haven't. They are of fantastic quality. So highly recommended. The products from hemplucid.com. Again, don't forget to enter the promo code SMASHOMASH to save 10% on your order. You can find some product reviews in our product reviews playlist about the Hemp Lucid products. And if you're viewing the videos on BitChute, get real. Subscribe over on YouTube. You're missing like 99% of the content. Today's featured product from the Amazon shop is the Anker Solix F2000 portable power station. Now this is just a battery backup, and so if you've got a power outage, this will power a lot of stuff. You can power up, it's a 2400 watt output. So it does have an RV port, 4 AC ports, 3 USB-C charging ports. This thing will run a lot of stuff for a long time. Highly recommend battery backups. You can also get all kinds. We put up like 4 different ones here. Some of them include solar panels. These are for different size things. Of course, battery backups are super useful to have in your car and so forth. So check those out on the Amazon shop. Today's featured product is being worn by me, yeah. Smasher Price, my first pandemic. A reference to the pathetic, ridiculous, and infantile response to a certain germ that everybody has a giant boner over. And this is one of our first pieces of merch. We decided that we wanted a souvenir. It's also got our .org website, smashomash.org, right there across the non-pharmaceutical intervention that was so, quote, effective, end quote, just as it's been so historically effective. A great reminder that the danger is not germs, but people. Smasher Price, my first pandemic. You can find links below the video to the Redbubble shop as well as on our homepage at smashomash.com. Here's a solar system forecast. Actually, it looks like tomorrow's new moon. There's where things will be in 1 week. We will have a crescent waxing moon by that point. And let's take a look at coronagraphs since we've had coronal mass ejections. So that is 66 frames from yesterday. It looks like we've got another comet showing up there. So it's a little tiny one. You can see it right down here. I didn't even see it when I did show prep. Right there. Little comet there. in the southwestern portion of the coronagraph, right above my pointer there. And there it goes. So that's yesterday's CMEs. Here are today's so far, an additional 30 frames there. And we're going to look at that a little more in depth, since some of those may have earthly directed components. Again, make sure you watch yesterday's daily space weather video if you want to hear the forecast for an incoming glancing blow coronal mass ejection. Anyway, there's Soho Lasco C2 and C3 together. So we do have one event here which might be interesting. Let's bring this back. So there's a series of CMEs happening there. That's like four or five CMEs happening all at once. Let's bring this back to about 12 o'clock. So here you can see a CME out of the west, also out of the southeast and the northeast and the north, all happening at once. That one out of the west, probably not earthly directed. But let's take a look at some more imagery here. We'll show stereo A on the left. And we like to show this graphic because stereo A is about to pass Earth, and Earth and stereo B are about to pass each other. So there's stereo A on the left and Soho Lasco C3 on the right. All right, so multiple events going on here. Yesterday, basically right as we premiered our video, some CMEs happening there. And let's see. I don't suspect that is earthly directed. It looks like it's got quite a lot of separation there. Around 1500 Universal Time yesterday. So no additional CMEs directed at Earth, I don't think. And let's show our custom coronagraphs. Those feature the Soho Lasco C2 and C3 together, along with the SGO 193 angstroms wavelength. And by the way, the likelihood of coronal mass ejections continuing is just about 100%. I'll say 100%, because we've got huge plasma filaments, some of which are clearly unsustainably large. This one is in the process of outflowing just to the southeast of that new sunspot that's risen. So that's the last 24 hours of coronagraphs. We'll get a little bit closer here. And you can see the source of some of those CMEs happening. 193 angstroms is pretty good at showing those filaments. We like to show 193 angstroms because it shows the extended corona, such as you can see down there in the lower left, the southeastern limb. That huge, unsustainably large plasma filament there hanging out. It's in the process of outflowing as we speak, actually. Last but not least, let's show just 193 angstroms by itself before we move on to filaments. And you may be able to see some of those huge filaments that we talked about earlier. They are large. They are charged. Yeah, they're electrically and magnetically charged. So here they are in hydrogen alpha from El Teide, Spain. So that's part of the National Solar Observatory. The NSO. Lots of filaments there, and if you want to name filaments after living folks, do it over on Twitter. Hashtag name that filament. Yeah, name that filament. Now, I would suggest naming this one right here, because this is the most likely one to find itself hurtling towards Earth. So once again, if you want to name filaments, follow us over on Twitter. Barely anybody does because, well, Social media is completely broken. And by the way, if you've unplugged from social media entirely and you're only viewing this video, you only view our channel and nothing else on social media, we don't blame you at all, because it has only gotten more pathetic since March of 2020, not less pathetic. So anybody out there who's claiming censorship has been fixed by Twitter and Elon, you're pathetic. You are a fanboy, and you are living in a delusional escape from reality. Censorship is not fixed. It's just as pathetic as it's been for the past 3 years. It's truly sickening, and if you have completely unplugged from social media, I don't know how you're seeing this video because YouTube is social media. These are interactive videos where you can leave comments. Anyway, again, we don't blame you if you've completely unplugged from social media. It is truly a disgusting pile of garbage. Check it out. Huge CME happening as we create the video. That one's great. It's got a huge, leading edge bubble formation. That is awesome. Check it out. There's like a bubble on the leading edge of this thing. See the way there's empty space around there? That is electricity and magnetism, folks. Yeah. It doesn't mean the universe is electric, but a lot of the activity happening there indeed is electric in nature. And no real astronomers are suggesting that Birkeland currents don't exist, because this is a common argument that we hear from herp-derps on the internet who are convinced that the universe is electric because they don't understand physics. And then they say, do you deny the existence of Birkeland currents? Nobody denies the existence of Birkeland currents. It's 150-year-old science. But yeah, huge magnetic loop there making its way out. I think I said that plasma in the southeastern limb was unsustainable. Well, there you go. Another forecast, 100% correct from the Smash News Network, least busted name in news. By the way, we've got more filamentary imagery for you here. We've put one more custom video together for you. This is 193 plus 304 angstroms. My personal favorite wavelengths to show filaments, although there are some other good composites that you can use from SDO. For example, 171 plus 211 works pretty well. Shows a little different features. This one's showing ionized helium in 304 angstroms and ionized iron, which brings us to bonus features. So we used to put these all different. We used to put these all on separate videos, but guess what it did? It reduced our views on YouTube. So they're back together now. That's why these videos, yesterday's video was 55 minutes long. Here's our satellite's community dashboard, and it's showing some minor surface charging hazards there over the eastern Pacific and western Mexico. Those surface charging hazards, as our regular viewers are well aware, are caused by low-energy electrons building up on spacecraft. And we've got a big increase in the electron flux, as you can see here in the past 3 days. The past about 18 hours here have featured a big uptick in the electron flux, an indication that the coronal hole high-speed stream is subsiding, although it's doing it slowly. There's the one-year graph, a huge uptick in the electron flux. And there is the forecast model, NOAA expecting a legit electron storm here coming. So this could cause some issues here. The ionosphere is in the process of puffing up, and we're going to show you that in a moment as well. So let's take a look at the F layer, which is located at about 300 kilometers of altitude, one slice of the bridge between Earth and space. And there's the vibrational frequency. And we are seeing significant anomalies here, which may or may not be evident to you. Don't worry, we'll show the anomalygram, which will basically spell it out in graphical form. So there is the anomalygram. It depicts anomaly in megahertz from a 30-day median. And we are seeing major anomalies here. So these low-frequency anomalies are most likely an increase in the density of the gas in the upper thermosphere, because keep in mind, folks, when geomagnetic storm conditions happen, the ionosphere puffs up. Yeah, it gets bigger. And that's likely what you're seeing here. The decrease in vibrational frequency likely caused by an increase in gas density, because, again, the ionosphere is puffing up. That's what those low-frequency anomalies depict. They are shown in red. High-frequency anomalies are shown in blue. That's probably little dips in the ionosphere. The most common place to see those would be, of course, right here at the South Atlantic anomaly, where there's a huge disparity in Earth's magnetic field strength. Anyway, here's the latest image. That's 11 o'clock Universal Time ionogram, and there is 11:15 Universal Time anomalogram. You can see there the ionosphere in the northern hemisphere puffing up. No real surprise as summer approaches on this side of the planet. We'll also show the total electron content forecast. Feel free to pause the video on this frame if you're not familiar with distances depicted here in miles. Here's the total electron content. The free electrons from your GPS satellite all the way down to your handset. We showed some significant anomalies yesterday. If you didn't see yesterday's daily space weather video, you probably missed them. And if you didn't see yesterday's daily space weather video, we frankly aren't surprised. We aren't even surprised if you didn't see this video, because the algorithms are completely broken and ridiculous. So that's the total electron content forecast. Free electrons in the thermosphere, ionosphere, plasmasphere, even the inner portion of the outer Van Allen belt depicted there. Ground level to about 12,500 miles of altitude. We'll also show just North America's anomalygram. This is anomaly from the 10-day average. And mostly low electron content anomalies here. This is literally a count of the electrons. You can see low electron counts there, especially over places like the southern U.S., Mexico, and Central America. Depicted in blue are those low electron contents. And we'll close out the space weather section of this video with the latest intensitygram and SDO magnetogram. Take a look at that new sunspot. It is currently only alpha class. However, this sunspot here is beta gamma delta class, the most likely class to produce large flares. These groups up here that's beta gamma delta class also. And this is a sunspot as well. So we're going to have two new named sunspot groups today. Not just one in the south, but this one up here also. That is also a sunspot. And by the way, that's good news for everybody who's concerned that the sun is shutting down. Lunatics who think the sun is shutting down, obviously they aren't looking at the sun. But you know, if they're forecasting disaster because the sun is shutting down, they should be happy that it isn't. Instead, all they do is double down and attempt to gaslight people. A truly pathetic response. It's about as scientific as flat Earth or chemtrails. Yeah. Anyway, here's your full disk rock back before we move to meteorology. We're going to do some wave chasing and looking at winds. So here we are. Croissant Earth depicted on a fake NASA Croissant Earth debunking spherical Adobe Photoshop template. We're looking at the world's strongest winds and highest waves. The seas are pretty calm here at the moment, actually. But to the west of the Drake Passage, you've got some 28-footers. Those are the world's largest waves. And it's also a pretty windy portion of the planet. Again, the seas are fairly calm here at the moment on a worldwide basis. And it's a pretty good day for Viking raids. If you're thinking about rowing across the North Sea in a longboat and trying to take over Scotland, today might be a good day to do it. Let's switch to our regularly scheduled meteorology segment here. There is the surface wind scenario for the Western world. Shout out to our viewers from all around the planet as the darkest days are upon you in Australia and New Zealand and Tasmania. These are the jet streams of the eastern world, and we've got a backward jet stream over the equatorial realm of Oceania and the northern Indian Ocean. A little bit of backward jet stream action there. Here are the jets of the west, getting a little bit more coherent in the U.S., but still some major bends here over the western U.S. and the Great Lakes region. Here are the surface winds of this side of the planet. surface winds of the central world, and the jet streams of the central world. By the way, the jet streams are the best global weather forecasting parameter. If you needed only one feature to forecast weather patterns, I would recommend the jet stream, depicted here by the 250 hectopascal winds. Moving right along to some more weather stuff. Let me refresh that, as we've got some significant storms here moving across Kansas as we produce the video. Looks like a little impulse there pushing them to the northeast, actually. And we'll show you why in a moment. Let's briefly zoom out here. How about if we show the whole world satellite view? There we go. That's pretty sweet. Give that a minute to spool up. Let me press refresh. It's not showing full screen. There we go. The windy.com satellite view. Oh, I know why. Because it doesn't like the polar region. Anyway, there we've animated the last 2 hours for you. Moving on to clouds and fog for the past couple of hours here over the Americas. Great equatorial cloud bands there. And some rapid cloud nucleation happening around Central America there, north of Panama. Check it out. Big time clouds there showing up north of the Panama Canal. Next, your weather.gov warnings. If your location is lit, head to weather.gov. These are too many for us to cover. The U.S., it's got a lot of counties. And those are the keys to your warnings. Excessive heat warnings there for the southern portion of the U.S. Also some flooding and some severe weather forecasted, and some flooding in Colorado and Kansas. Here is your pressure and precipitation forecast based on the GFS 72-hour model. As snow is forecasted for Washington, Idaho, California, Montana. Yeah, some snow in the forecast there for the next 72 hours. How about them apples? Is it an indication the sun's shutting down? Have you looked at the sun lately? Did you watch the beginning of this video? Here's our total accumulated precipitation forecast in inches. Alberta going to get some extreme rain up there. Look at that. Huge areas with 6 inches of rain coming. Also some heavy rains coming to Arkansas, Louisiana, Alabama, Mississippi, Georgia, Florida, Kansas, and Illinois. Also Iowa expecting 4 inches of rain. That's your 72-hour GFS total accumulated precipitation forecast. And let's do a jet stream forecast to see if it's going to get a little more coherent. Nope. We're still going to have extreme jet stream incoherence around the Great Lakes. By far Earth's largest body of fresh water there, the Great Lakes Complex. Quite an interesting feature on the planet indeed. That's your 72-hour, 250 millibar wind speed forecast based on the GFS model. Actually, the jet stream is going to get less coherent here in a couple of days, so you can expect more funky weather patterns to continue. Nope, it's not caused by HAARP or geoengineering or chemtrails or any other nonsense people believe in on the internet based on zero science. Next, our lightning mapper, and we had some heavy lightning there across the Gulf states. Also Kansas had lightning sweep across the state, and that's some pretty lousy feeds there. Let's move to our real-time lightning map, courtesy of lightningmaps.org. Some terrestrial strikes there in Central Asia, in Europe, and in the Gulf of Mexico. Besides that, things are pretty calm in the U.S. as far as lightning goes. And things are pretty calm at smashomash.com, probably because you haven't visited the site. So the official website of the Smash News Network, least busted name of news, is smashomash.com. We launched it back in February of 2019 because In 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped the maximum security, pathetic social media stockade on Facebook, where we survive in the internet underground as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you certainly can hire the Smash Team. There's a link right there and right there. Just click on that, and you'll get things like email alerts, even at the bronze level for things like natural disasters and space weather events. If you want additional content, especially join at the gold level. There's also a silver level. It costs you a whopping $2.99 per month. So for you hundreds of people that watch the videos every day on YouTube, how about supporting the channel? Comfortable in the knowledge that we make just this side of nothing to put the content on YouTube. Yeah, even though our views have risen 90,000 views per month in the past 28 days. Smashomash.com/Smash Team, the official subscription services site of the Smash News Network, least busted name of news. Thanks especially to our gold and silver Smash Team members, since these videos are brought to you not only at massive personal risk and expense by Smash staff and I, but also the contributions of gold and silver Smash Team members. We'll close out the video with U.S. Doppler radar, clouds and fog, and don't forget water vapor. Now, once again, like I said, what the hell is that? Why are you turning blue at the end of my feed? Don't be an idiot. All right, there we go. So as we said, there is an impulse here behind this system. And it's really this string of dry massive air right here that's providing that. Also, this low down here is helping to pull things to the south a little bit. So the water vapor map will really help you out if your Doppler is looking unclear as cold air comes down across the Great Lakes into Pennsylvania from Canada once again. Here's your recap. U.S. Doppler radar. Clouds and fog. And we'll close out with water vapor. Anyway, thanks for tuning into the Smash News Network, least busted name of news. It's time to head back to the bunker. In the meantime, may that solar wind be at your back.